In this video, we're going to continue our discussion of vector value by talking about what's called an initial value problem. These problems you may have seen in Calc 2. It really depends on the curriculum and your professor. If they decide to skip it or not, they're free to do that. This is really the basis of all Diffie-Q in a way. In Diffie-Q, we're given problems, initial value problems, and told to work backwards. You guys have done this with functions, but you haven't done it with vectored value functions. It works the same way. We're just going to have three components. So they gave me R prime, and they want us to find R prime. They also gave me an initial value. That's why it's called initial value problem. So they said when I plug in 0, that's the vector I get. Use that, and we're going to use that to find C. Okay, so to find R prime, I'm going to take X, I'm going to find each component. So X prime of T is equal to 4. So that tells me X of T is equal to the integral of 4 dt. Okay, the integral of 4 is 4t plus c1. Okay, y prime is equal to negative 5t squared. So y of t is equal to the integral of that dt. Now remember, we just up the power and divide by the new one, so we got negative 5/3 t3 plus c2. And then we have z prime of t was given to us. It is t. So z of t is the integral of t dt, which is 1/2 t squared plus c3. Okay, notice we have all these c's. I do have my vector value function now. My vector value function is r of t. And then I got 4t plus c1. I got negative 5/3 t cubed plus c2. And then the last component is 1/2 t squared plus c3. Right? And we can use now the initial value to help us out. If I plug 0 into what I have, I got c1, c2, and c3. And I am going to set that equal to the given, the initial value, the IV. The initial value is 1, 0, 1, right? I, J, K. So that tells me that C1 must be 1, C2 must be 0, and C3 must be 1. So now I actually can finish my problem. R of t is equal to 4t plus 1, negative 5/3 t cubed, and then 1/2 t squared plus 1. Right? And that is our vectored value function. We work backwards. Remember, the initial value is what allows me to find my constants. Sometimes they'll be this clean where you can just like literally look at it. Sometimes you're going to have to take this component, whatever that's going to be, and set it equal to that one and solve. It may not just be a C1. It may be a 4t squared plus C1 equals this, right? Or when you're plugging your 0, and you may get 36 plus C1 equals 1, and you got to figure out what C1 is. You just work backwards. All right, let's get one that's a little deeper. We have our second derivative. The second derivative looks like that. Okay, so, and then they give me two IVPs, or two IVs. This is another IVP, initial value problem. We gave me a second derivative, then they gave me a value, notice, for R prime, and then they also gave me a value for R. So I can work backwards to get to each part. So X double prime, start working piece by piece, 3e to the t, which tells me X prime is the integral of 3e to the t dt, which is just 3e to the t plus c1. Okay, then I have y double prime, which is going to be negative secant squared t. So that means y prime is equal to the integral of that function. If you remember that, that is tangent with a negative. So we get tangent, negative tangent t plus c2. And then our last component with the second derivative they gave us is t, negative t to the 1/2. I'm going to do it that way to make it a little easier on me. It's the integral of t to the 1/2 dt. We increase our power, divide by the new one. If I go up by 1, it's 3/2. If I divide by it, I get negative 2/3. 3/2 plus c3. So this means that r prime of t is equal to 3et plus c1, negative tangent t plus c2, and then negative 2/3 t to the 3/2 plus c3. So I can use the initial value thing here. If I plug in 0 for each one of those, okay, I get, let me fix that. I get e to the 0 is 1, so I get 3 plus c1. Tangent of 0 is 0, so I get c2. And then 0, I get c3. And we set this equal to the initial value. So that is, for the primes, it's 1, 0, -1. So we set each component equal. 3c1 equals 1. So if I solve that, I minus 3, I get -2. c2 equals 0. And c3 equals -1. So r prime of t is equal to 3e to the t minus 2, negative tangent t plus 0, and then negative 2/3 t to the 3/2 minus 1. Okay, now I have r prime, and we get to start the process over, going through all my primes. So we got x prime of t is equal to 3e to the 2 minus 2, which tells me x of t is equal to the integral of that, dt. So we get 3e to the t minus 2t plus c1 star. I'm just going to call it something different, so I put a star on it. I don't feel right calling it c1 because it's not c1. It's a new c1. We could call it, I guess, c4 if you want to go through it that way. I like the stars, I like the 1 to keep it track with that being x. So y prime t is equal to negative tan t. That integral, y of t, equals, okay, and I'm going to go ahead and break this up. This is negative sine t over cosine t. That's the definition of tangent. We're going to do a u sub. If u is cosine, then du is negative sine dt. That actually takes care of that exact thing. So I get negative 1 over u du, which is going to be the ln of the absolute value of cosine t plus c2 star. Okay, that wasn't so bad. It looked bad, but the u sub takes care of that pretty quick. Z prime of t equals negative 2/3 t to the 3/2 minus 1. So z of t is the integral of that. There we go. dt. So if I raise the new power, it is 5 over 2. And then if I divide by 5 over 2, it's multiplying by 2 over 5. So we get a negative 4 over 15 t to the 5/2 minus t. And that's going to be we also have a c3 star. Okay. Oh, forgive me, I don't know where that added that in. It made me jump quite a bit. Give me a sec. I'm sorry, guys. It jumped me back up. Definitely to the wrong sections. Maybe just close your eyes through this. Forgive me. Gosh. Like, I've already lived through that. And that. Alright, I got quite a bit. You've done so much already. We're almost there. Okay, one more, I think. Yeah, it's at the end of this. All right, I did find it. It's here at the end. Forgive me, I don't want to start the video over. I know this has happened a few times. I touch a part of the screen and it scrolls up really quick. So forgive me. Okay, so now I have that function r of t, which is going to be equal to 3e to the t minus 2t plus c1 star, comma, and then the next one was ln of cosine t plus c2 star, and then the last one was negative 4/15 t to the 5/2 minus t plus c3 star. Now the initial value, this is what I was trying to do earlier. I'm on the right page. Let's see if I do it correctly this time. It did not. Well, there was the fix. Easy fix. Oh, I see what it is. We're just going to write on it. I don't know why it's not working for me to add another page, but I'm getting a bit frustrated, so I'm going to stop. Okay, we're plugging in 0 here. So I got 3 plus c1 star. If I plug in 0 for cosine, cosine is 1, ln of 1 is 0, so I get c2 star. Plugging in 0 for that third one, we get c3 star. And then we're going to set this equal to our initial condition. So let me scroll up real quick. The initial condition for r was 3, 1, negative 1. 3, 1, negative 1. So this tells me that, and I'm going to go up here to kind of save room. Forgive me for writing on top of all this. I got 3 plus c1 star is equal to 3. So that means c1 star is equal to 0. c2 star is equal to 1. And c3 star is equal to negative 1. So we can write out our final answer, r prime of t is equal to that whole function, 3e to the t minus 2t plus 3, plus, or then the second component, ln of cosine t plus 0. Oh, hold on one sec. I messed up. This isn't a 3, it's a 0. Right? It comes from, those values come from here. There we go. All right, and then c2 is 1. And then C3, I got negative 4/15 t to the 15 over 2 minus t minus 1. There is my answer. These are longer problems. Just be careful because you got to do 3 integrations for each step. It's very, very easy to make a mistake. There could be a mistake in here. Again, if you catch an error, you can let me know. I typically, if I make a small arithmetic error, I don't re-record my videos just because I assume that you can handle that. If I make some type of big foundational mistake, I will go through and re-record. I just need you guys to let me know if certain mistakes are made.